How strong is a chain? The answer is it's only as strong as its weakest link. So in general, a calculated answer cannot be more precise than the least precise measurement from which it's calculated. Just like a chain is only as strong as its weakest link, your answer can only be as precise as the least precise measurement that you use to get your calculated answer. So this is going to involve you rounding calculated answers to a correct number of significant figures, so we don't misrepresent our calculated answer as being more significant or precise than it actually is. So step 1 is to decide how many significant figures are needed. Step 2 is to round to that many digits, counting from the left. If the next digit is less than 5, we drop it, and if the next digit is 5 or greater, we round it up by 1. So let's do some practice. Round off each measurement to the number of sig figs that are shown in the parentheses. So here's our number, 314.721 meters. And they want you to round that to 4 significant figures. So I'm going to count from the left, 1, 2, 3, 4. Okay, 7 is my 4th significant figure. I look to the next number. It's 5 or less, it's less than 5, so I'm going to drop it. So my correctly rounded answer is 314.7 meters. Let's do the next one. 0.01775 meters. We need to round that to 2 significant figures. So let's remember our Atlantic Pacific rule. I want to count to the second significant figure. I have a decimal point present, but these leading zeros don't count. I can only start counting significant figures at the first non-zero. So the 1 is my first significant figure, the 7 is my second significant figure. So I look to the next number, 7 is 5 or greater, so I'm going to round my second significant figure up by 1 to 0.018 meters. Okay, let's do number 3. 8,792 meters. We need to round that to 2 sig figs. So if I go to the second sig fig, which is the 7 here, and I look to the next number, it's greater than 5. So I'll round this up. Very common mistake here would be to round this up to 88 and just say 88. But 88 is not roughly equivalent to 8,792 meters. If I owed you $8,792 and I said, well, let me round it up for you and pay you back 88, you probably wouldn't be too happy with me. Same goes for this number here. I can't just leave it at 88. So I actually have to add in some zeros here. So 8,800 is roughly equivalent to 8,792. Okay, so I'd like you to take your answers from the last set of practice problems and convert them into scientific notation, just to give you some practice on scientific notation conversions. So here are our answers. Go ahead and pause the video and convert them into scientific notation, and when you're ready, unpause it and we'll go over it. Okay, so for number 1, the correct answer in scientific notation is 3.147 times 10 to the 2 meters. For the second one, we're going to have to move the decimal point 2 places to the right, so that'll give us a negative exponent. So we'd get 1.8 times 10 to the negative 2. And for our third answer, we're going to get 8.8 times 10 to the negative 3. So how do you decide how many sig figs you need to round to? So the rules are different for different mathematical operations. So for addition and subtraction, the rule is the answer should be rounded to the same number of decimal places as the least number of decimal places in the problem. Notice I didn't say sig figs, because we don't care about sig figs when we're adding and subtracting. We only care about decimal places. The trick, though, is that these questions will always ask you to round to the correct number of sig figs. It's up to you to look at the problem, notice that it's addition and subtraction, and say, I don't care about sig figs, I don't care what the question's asking, I care about decimal places. Okay, so here's an example problem. Calculate the sum of these 3 measurements and give your answer to the correct number of significant figures. But notice that we're adding 12.52 plus 349 plus 8.42 meters. Okay, I don't want significant figures. I see that addition sign or the subtraction sign. I want decimal places. So if I punch this into my calculator will say 369.76 meters. Then I need to ask myself, how many decimal places do I want to round to? The rule is I want to round to the least number of decimal places in my least precise measurement, which is measurement number 2, 349.0. That only has one decimal place. So I want to round my calculated answer to one decimal place. So that rounded correctly would be 369.8 meters. You try this next one. Calculate the sum of these two measurements and give your answer to the correct number of significant figures. So if I add these two up, the calculator will say 18.734 grams. The question is, what should I round to? I see the addition sign. I want to round to decimal places, the least number of decimal places, which in this case is 2. 6.80 has 2 decimal places. So that answer correctly rounded to 2 decimal places, of course, is 18.73 grams. Okay, so remember, the way you decide how many sig figs you need depends on the type of math you're doing. So for multiplication and division, the rules are different. Now we want to round our answer to the same number of significant figures as the least number of significant figures in the problem. So now I count sig figs and round appropriately. So here's an example. Perform the following operations. Give your answer to the correct number of significant figures. We are multiplying 7.55 meters times 0.34 meters. So if I punch that into my calculator will say 2.567 meters squared. So how many sig figs should I round to? So let's look at our two numbers here. 7.55. The decimal point is present, so I'm going to go Pacific to Atlantic starting with the first non-zero. The 7's a non-zero, so it's significant, and so is every number after it. So this number here has 3 sig figs. Let's look at this number. A decimal point is present again, so I will also go Pacific to Atlantic starting with the first non-zero. This 0 doesn't count. Here's my first non-zero. It's significant, and so is every number after it. So this number has 2 sig figs. So I want to round my answer to 2 sig figs. Any answer greater than that, like my calculator says, 2.567, that's over-representing how significant my calculation is. You can't do that in chemistry. So I want to take that number and round it to 2 sig figs. So I'm going to count from the left, 1, 2. The 5 is my second sig fig. I looked at the next number, 6. The 6 will round this 5 up 1. So my answer is 2.6 meters squared. All right, you try this next one. We're going to divide 2.4526 by 8.40 meters. Okay, if I punch that into my calculator will say all that. And if I wrote that down in my answer, that would be way over representing how significant my measurements were. So the question is, what should I round to? I'm dividing, so I want to round to the least number of significant figures. If I look at this first number here, I have 1, 2, 3, 4, 5 significant figures. These are all non-zeros. They all count. Okay, on this number here, I have 3 significant figures. There's a decimal point present, so I'm going to go Pacific to Atlantic, starting with the first non-zero. The 8 is significant, and so is every number after it. So I have 3 significant figures in that number, so I should round my answer to 3 significant figures. So we go to our calculated answer, and I go to the third significant figure, 1, 2, 3. It's a 1. I look to the number next to it, it's a 9. That would round this 1 up to a 2. So my answer is 0.292 meters. So to summarize what we've learned so far, when doing math with actual numbers that come from measurements, you have to round your answer to something specific. You can't just write down what your calculator says. It's over-representing how good your calculation is. So when multiplying or dividing, we want to round to the least number of significant figures in your measurement. But if you're adding or subtracting, you actually want to round to the least number of decimal places in your least specific measurements. Even though the question is going to say round to the correct number of sig figs, you want to do decimal places. It takes a little practice to remember the difference between these two, but you'll have plenty of opportunity to practice these in class. I hope this helps, and if you have any questions, please let me know.